Hello everyone, welcome back to my channel Decode Data with SKD. In case of transportation problem, we use NWCM method, LCM method and WAM method to find out the initial basic feasible solution. But the real question comes only when we find the initial basic feasible solution. The first question is whether this particular solution is optimum or not. And if it is not optimum, can we optimize this particular solution or not? Here the role of Modi method comes into the picture. Modi method helps us check optimality of a transportation problem and tell us whether the current solution is minimum or not. Right? Minimum or maximum, whatever you can say, right? Especially in case of transportation cost, we'll say minimum because normally we talk about the cost. And if it is not optimal, Modi method show exactly how to improve it step by step to reach to the optimum solution, right? So in this video we will understand the concept of Modi method first. We'll learn how to calculate the value of UV. Value of UV is one of the important point in case of Modi method that will help us to reach to the optimum solution, right? Then we'll check the optimality condition and we'll find out whether the solution is optimum or not. And finally we will reach to the optimum solution if it is not optimum in case of initial solution, right? This is what we will discuss in this particular video. I will explain everything step by step in this particular video and strictly according to the exam requirement. So I request you to watch this video till end and share with your friends. So let's begin with Modi method and take our transportation problem to its final optimum solution. Fine. So now when we have a transportation matrix, we use any of the method like LCM, WAM, NWCM to find the initial basic solution. Now in your screen we have one matrix, that is the solution of this matrix is 779, and the solution, the initial basic feasible solution, was calculated with the help of WAM method, right? So now from here I am taking this to check first of all whether the solution is optimum or not, right? Now to check whether this solution is optimum or not, what we will do is, the first step that we will do is we will basically make U and V like this, V for all the columns and U for all the rows, U1, U2, U3, V1, V2, V3, right? This is the first step we'll go. So we allocate V1, V2, V3, V4 and U1, U2, U3 depending upon number of rows and number of columns we have. Fine. Now the next step is basically we have to find out the solution, or basically we have to find out the value of U1 and V1, right? Now because we don't know the value of U1 and V1, so what we'll do is we will take any of the value of U1, 2, 3 or V1, V2, V3, V4 as 0. How we decide this? We decide this based on number of allocation we have, right? So let's see. In this particular first row, the number of allocations are 2. In the second row, again the number of allocations are 2. And the third row, number of allocations are 2, right? So row wise if we go, we have maximum 2 allocations, right? Now if you go to column wise, in this particular column, one allocation is 1. In the second column, V2 allocation is 1. V3 allocation is 1 and V4 allocations are 3. So this is basically the column in which we have maximum allocation, right? So what we'll do? We will select the column or row in which we have the maximum allocation. In this case, it may be that you have only 2 maximum, right? In each and every row and each and every column, we have 2 to 2 allocation, right? In that case, you can take any one. Any row or any column you can select. In this case, what I am doing is I am taking the the fourth column, because in fourth column maximum number of allocations are, right? So let's put that column value as 0. So say this is what we are talking about, value of v, value of v, and this is what we are talking about, value of u, right? So all the values of u1, u2, u3 will be mentioned here in this area, and v1, v2, v3, v4 mentioned here. So let's take, because this column is having maximum allocation, so let's say this is 0. Now once I have taken one of the value as 0, right, we have to calculate rest of the values of u1, u2, u3, v1, v2 and v3, because v4 is already 0, right? How we will calculate? Simply calculate like this, right? The formula is this value and the intersection point, right? Now you have to understand that whenever we have to calculate the value of u and v, we have to just talk about the allocated cells only, right? So this is the one that is in red, this is one allocation, second allocation, third allocation, this is fourth allocation, this is fifth allocation, and this is sixth allocation. So we will take just these cells to calculate the value of u1, u2, u3, v1, v2, v3, right? Now, so what I'll do is, for u3, v4, the cell value is 20, right? This is u3 and this is v4, so cell value is 20, right? So what we'll say? We'll say v4 plus u3 is equal to 20, right? Now because v4 is 0, so u3 will be 20. So I'll mark u3 as a 20. Clear? So now 20 is basically the value of u3. Fine. Now what we have to do is, let's move on to another cell, the top one, right? Now the column will be same, 0, and this is basically the cell. So now if I'll say here, I'll say v4 plus u2 is equal to 60. v4 is 0, so u2 is equal to 60, right? So you have to write 60 here. Clear? So this is what 60. Done. Now we have to move to the top, this row, this particular cell. Now this cell is basically what? This cell is v4 plus u1 is equal to 10. v4 is 0, so u1 is equal to 10. So I have to write 10 here. So let's write 10 here, right? 10. Fine. So this value of u1, u2 and u3 is over, right? Now we have to move down to the another value of v1, v2 and v3, right? Now let's say value of v3, because this column is allocated the corresponding value of u2 and the corresponding value of v3, right? Now in this case, if you go for, you'll find u2 plus v3 is equal to 40, right? u2 is 0, that you have to find out. v3 is basically, u2 is 60. In this case u2 is basically 60. So 60 plus v3 you have to find out, and 40. So if you calculate this, it will be v3 is equal to 40 minus 60, so that is minus 20. So we will write the value 20. This is your value of u3. Now we have two. This is the one, and this is the second one. Now let's take any one. Fine. I have taken this. Now this. So now this will be u3 plus v2 is equal to 8, right? Now u3 is basically 20, v2 you have to find out, and 8. So v2 will be 8 minus 12, that is, sorry, 8 minus 20, that is minus 12, right? So now you have value of v2 is minus 12. Now you have to find out the value of v1. So v1 we can find like this, right? So value of v1 is 9. So now you have all the values u1, u2, u3, v1, v2, v3 and v4. Fine. Now this is the place where you have to find out the opportunity cost, right? Now what is the opportunity cost? See, our objective in this case is to minimize the cost, right? Now if you have to minimize the cost, you have to find out the cells that are not allocated, right? So this is the one cell that is not allocated, this is the another one, this is the another one, and this, and these are the 6 cells that are not at all allocated. Now what is opportunity cost? Opportunity cost is basically the cost can be defined as the cost if something we allocate to these particular unallocated cell, that what will be the change in the final cost, right? So in case of unallocated cell, if we place something, if we allocate something, what will be the change in the final cost? That is basically the opportunity cost, right? So now we have to calculate the opportunity cost for all the cells that are normally unallocated. Clear? How we will calculate the opportunity cost? Now this is the first cell, I have to calculate the opportunity cost. So what I'll do, I'll take this 70 minus, now if you see 70 is a combination of u2 and v1, right? So if you will say this cell, particular cell 70, this is u2 v1 cell, right? So we'll say 70 minus u2 plus v1. Clear? Now 70 minus, what is u2? u2 is 60 plus v1 is 9, right? So 70 minus 69, that is 1. So the opportunity cost for this particular cell, the dark cell, is basically the 1. So I have mentioned 1. Now let's take the another cell, 40, right? Now in this case 40 is basically u3 plus v1, right? Right, u3 v1. Now so 40 minus, so this 40 minus u3 is 20, u3 plus v1, right? So now 40 minus 20 plus 9, so 40 minus 29, now 29 is, that is 11. So opportunity cost for this is 11. Clear? So this way we will calculate the opportunity cost for all the cells. So now all the cells are having the opportunity cost, all the empty cell, non-allocated cell are having the opportunity cost. Now what is this opportunity cost indicates? That is one of the most important things that you have to understand. Now this opportunity cost indicates, let's take one example, let's take the just a minute. Yeah, let's take this particular cell, right? What it means, what this one indicates, this one indicates that if you assign something, if you want to allocate, if you allocate something to this particular cell, the cost will be increased by 1, right? Because there is a positive sign, right? Now go to this one, this particular cell. If you allocate something in this cell, the cost will be increased by 11, right? Now, because this is the minimum case, so my job is to reduce the cost. But in both the cases, cost is increased. In this case, if I allocate something, cost will be increased. In this case, if I allocate something, cost will be increased. In this case, if I allocate something, cost will be increased, right? But in this case, if we allocate something, because of this minus sign, this indicates that cost will be going to reduce, right? So this is the cell we have identified where we have to allocate. Now, this opportunity cost also tell you whether the solution is optimum or not. So let's take the condition. The condition is what? If any one of the opportunity cost is negative, your solution is not optimum. So the solution came with the help of WAM was not optimum at all. Clear? That solution was not optimum. So now you know that solution is not optimum. And how do you know that? Because all the cost, opportunity cost you have, right? Let me just write like this. Right now. So we have 1, we have 11, 32 minus 18, 40 and 70, right? All these costs except 1, all the costs are positive, but 1 is negative. Even if a single is negative, it means your solution is not optimal, right? Fine. So this is the first thing. Now let's just now, because the solution is not optimum, so now we have to convert it to optimum. Right. So let's talk about the optimality condition. The condition for optimality is all opportunity costs must be positive or 0, right? In case of minimization, if all the opportunity costs are positive or 0, you have the optimum condition, right? Because in this case we do not have the optimum condition, so we have to convert into optimum, right? To convert into optimum, we have to draw the path. We have to draw like these paths, right? This type of path we have to draw. So to draw this path, we have some you can say some condition, right? Conditions are when you have to draw the path, right? In case of to convert into the optimality, path must end from where it was started. So it's like from where it is started, it will finally move and reach to that position only, right? That is the first condition. Second is you cannot, because you see these are the cells, right? If you see these are the cells, right? You cannot move like this. Either you move like this or this, but you cannot move like this, right? You cannot move diagonal, right? And from wherever you will take the turn, from wherever you will take the turn, there must be some allocation. If there is no allocation, you cannot take the turn. Clear? So this is what you have to do. Now let's move on to the matrix again. This is what your matrix is, right? And in this matrix, we have one cost, that is basic. We have one cost 18. This is negative. So this is the cell where we have to allocate, right? Now from this particular cell, we have to draw the path, right? How you will draw the path? From wherever you go, whether you go right, left, top, bottom, you have to finally draw the path where the path will reach again back to the same position from it started. Second, all the turn must have the allocation and should not move diagonally, right? Clear? Now draw the path. So let's start from 30. I'll move down to the 60, because if I'll take the turn from 70, that 70 is fine, but from 70 I cannot take the turn anywhere, because 70 there is no allocation in 70, right? So I move down to the 60. From 60 I can move even up and down both the sides. So either I'll go to So in this case, I can go even up and down, both the side. But if I'll go to up, I can take turn from here. But the path cannot be completed. So what we'll do, we'll take the turn from 60 down, right? And then from there I'll turn, because the allocation is there. I'll reach to the 8, and then again I'll turn back, and there is a path. So this is the path. Now in this path, if you see, allocation is at the corner, this is the second corner, and this is the third corner. All the three corners we have the allocation. Clear? So this is the way you have to draw the path. Now, once the path is done, what you have to do is, the next step is, the place from here we started, marked it as plus. Okay, so what you have to do, you have to mark it as plus, because this is the place from here we started. So mark it as a plus. The second turn will be marked as negative. Third turn will be marked as positive, and the fourth turn will be marked as negative. Right? So first, third, fifth, seventh will be positive. Second, fourth, sixth, eighth will be negative. So odd number will be positive and even number will be negative. Clear? Fine. So now you have marked this as a negative. Done. Now what you will do is, you will just check the cells where you mark negative. So in this case, we have only 4 turns. 4 turns, right? You may have 10 turns. So based on that, you have to mark plus and minus, right? Now in this particular case, because you have 4 turns and only 2 negatives are there, this and this, out of this, just find how much is the allocation. So in the first cell there is a allocation 2, and the second cell there is a 8. In this cell we have allocation 2, and this cell we have allocation 8. Right? Now, out of these, so suppose you have 10, so you must be having 10 allocations. Out of these allocation, right now we have 2 allocation. Out of this, whichever is the minimum, we select this. So I have selected 2. Right? For what I have selected? You know, when 18 was there, minus 18 was there, I said that this is the cell where we have to allocate. So to allocate, to assign something in this particular cell, I have taken 2. So what I will do? I will just move and assign this particular 2 to this particular cell. Right? Fine. So now what I did is, now what I did is, I will assign it as I will assign 2 here. Just let me just change the color so that it will be visible. Right. So I have assigned 2 here. Right. So this will be 0 now. Now, when we will do this type of allocation, see, there will be some disbalance, right? Matrix will be unbalanced. So what we'll do? 2 and 8 will be 10, whereas you have the demand of only 8, right? So here we have demand of 2 extra. So we will reduce that extra from here, right? Marked as 6. Now, in this case, this is 6 and this is 10, 16, where the supply is 18. So what I'll do, I'll add 2 here. So it's simple. You have my plus, minus, right? What you will do, the number that you have selected to add here, subtract from here, right? So this was 0 allocation, so will be 2. This was basically 2, so minus 2. This is the second. Third one is 10 plus 2. This is 12, right? And this is basically 8, right? So 8 minus 2 is 6. So this is converted to 6. Now this way your matrix is again balanced. Clear? Now when the matrix is balanced, you will reach to a new matrix like this, right? Here we have 2, here we have 6, here we have 12, and here the 2 allocation, that allocation was removed. So this is the new matrix, right? Why we have find this matrix? Because what happened is IBFS was calculated, then we checked, and in checking we find that it is not optimum, right? So because it is not optimum, so we have to make it optimum. To make it optimum, this allocation was done. 2 was removed from here and added here, and so on, right? Now we have new matrix, right? Now again we check optimality, right? So before checking the optimality, we have to find out the IBFS, right? So this is the new matrix and IBFS is basically counted. Now 19, then 10-2, then 32, and new is 743, right? Of course it is reduced from the previous one, right? This is clear. So now what we did is we have checked the optimality. Because optimality was not there, solution was not optimum, so we have created new matrix, and after new matrix again we have calculated the IBFS, that is 743. Now again we have to check whether this is optimum or not. So what we will do now, again we will go for the U and V allocation. The same procedure we have to basically repeat. This entire same procedure we have to repeat, because we have to check whether the solution is optimum or not, right? Now we have to calculate the value of U and V. Clear? Up to this one I think things are clear. Fine. Now because we have to calculate the value of U and V, what we have to do is, right, now in this, see, there are two allocation in second row and two allocation in third row, right? Two allocation here, one here, two allocation in this column and one in this column. So let's take any one as a 0. So let's take this as a 0. I have taken this as a 0. Now because this is 0, so okay, I can calculate this. So what will be, let's say this is x, so 0 plus x is equal to 20. So x is equal to 20, right? Now I know this, so I can go for this 10. Then 19 and 10 is known, so I can calculate for this. Let's say this is x, right? So x plus 10 is equal to 19. X is equal to 9. So this will be 9, right? Now this is there. Then 10 is there. Fine, I have calculated this. Right. So now I have to calculate for this. So what I'll do, I'll say, let's say this is x. So x plus 20 is equal to 8. So x is equal to 8 minus 20. So x is equal to minus 12. So let's make it x equal to minus 12. Clear? Now, because I know this and this, so I can calculate this, right? So this question mark plus minus 12 is equal to 30. So question mark is equal to 30 plus 12, that is 42. So make it 42, right? No, sorry, not this one. This one, 42. This is 42, right? And then when you know this, so you can calculate this. So let's say this is y. So y will be y is equal y plus 42 is equal to 40, right? So y is equal to 40 minus 42, so minus 2. So this will be minus 2. Clear? So this is the way we will calculate the value of. Fine. So this is the way we will calculate the value of. Now let's just wait, let me erase everything. It's clear. Right? Fine. Just clear. Fine. Now, so value of U and V is there. Now we have to calculate the opportunity cost, right? Opportunity cost, right? Opportunity cost we will calculate for unallocated cells. Clear? Just mind it, and unallocated cells. So let's take the 70. So what I'll do? 70 minus this plus this, right? 42 plus 9, right? So 42 plus 9 is 51. So this is 90. So the cost here, which is 90. Okay. Now let's move on to this one, 40. So we'll say 40 minus 20 and 9. So 20 plus 9. So this is 11, right? I'll mark it as 11. Clear? Now let's move on to 30. So I'll say 30 minus 10 and minus 12. So 30 minus 10 minus 12. So 30 minus 2. So this will be 32. So this is 32. Clear? Now let's move on to this one, 50. So I'll say 50 minus 10 and minus 2. So 10 minus 2. So 50 minus 8. So 42. So this is 42. Clear? Now let's go move on to 60. So say 60 minus 42 and 0. 42 plus 0. So 60 minus 42, that is 18. So let's say this is 18. Clear? So now if we go, we have all cost. We have all, that is 19, 11, 32, 42 and 18. Let me write. So this is basically 19, 11, 32, 42, 18, right? Or and let's 70 also, right? So let's say 70 minus 20 and minus 2. So 20 minus 2, that is 70 minus 18, that is 52. So this is 52. Just check if I have done right? So 52. So now just see, all the opportunity costs are positive. All are positive. What this indicates, that any of these vacant cell, if we allocate whatever, the cost will increase because the number are positive. It means the solution, that is 743, is the optimum solution. Clear? So what we did in this one, first of all, we have calculated the initial basic feasible solution, then we checked the optimality, and because optimality was not there, so we have converted into optimal, and then finally we have checked the optimality, right? And this is what the process you have to repeat till you find the optimum solution. Suppose in this case, if this 743, suppose this is the negative, suppose, let's say, then what you have to do, again you have to draw the path, you have to do the allocation, you have to balance the equation, the matrix, and then again you have to find out the initial basic feasible solution, and then again you have to check. So this is the entire process you have to repeat again and again till you find the initial basic feasible solution. Fine. So this is what basically the values are, and all the opportunity costs are positive, so your solution is optimal, right? I hope you it's clear to you all. I request you to please like and subscribe my channel. Please write your questions in your comment box. I will read and reply for all of them. Till then, thank you for watching this video. See you in the next video. Have a nice day.